Lastly, from the enthalpy module, we can find the delta H of reaction, also looking at the bond enthalpies. So the energy required to break each of the bonds in the reaction, and the energy released when we form new bonds in this reaction. And so all we would do is go to the table of bond energies that's provided. We would go to the table, we would look up and find the energies for each of the bonds in question. And so we can see in this structure, I've got carbon-hydrogen bonds, I've got chlorine-chlorine bonds. I'm going to make carbon-chlorine bonds, and I'm going to make hydrogen-hydrogen bonds. So the bonds in question that we want to know the energy of is carbon-hydrogen bond, chlorine-chlorine bond, and those are from our reactants. For the products, we want to know the energy of a carbon-chlorine bond and a hydrogen-hydrogen bond. And so when we go and look up the energy from that table provided, we see that a carbon-hydrogen bond is about 415 kilojoules. A chlorine-chlorine bond is 243 kilojoules. Carbon-chlorine bond is 330 kilojoules. And a hydrogen-hydrogen bond is 436 kilojoules. We can do the same summation calculation where the delta H of this reaction is the sum of the energy of the bonds broken minus the sum of the energy of the bonds formed. And this depends on the number of each bond. So if we go and take a look at the reaction, right, we're going to break 4 carbon-hydrogen bonds. We're going to break 2 chlorine-chlorine bonds. And in the process, we're going to form 4 carbon-chlorine bonds and form 2 hydrogen-hydrogen bonds. So the delta H for this is going to look like the sum of the energy of our bonds broken. So bonds broken, I've got 4 carbon-hydrogen bonds at 415 kilojoules plus 2 chlorine-chlorine bonds at 243 kilojoules minus the bonds that I'm making, a carbon-chlorine bond, so 4 of those at 330 kilojoules plus 2 hydrogen bonds at 436 kilojoules. The next step, we're going to multiply by the number of bonds and the energy of each of those bonds. So I get a delta H equals approximately 2,146 kilojoules for the bonds broken minus 2,192 kilojoules for the bonds formed. Subtract those two and I get a delta H overall for this reaction of about a negative 46 kilojoules. All right, again, the important thing here to do was just to use that table provided and look up the bond energies of each of those, the bonds that were broken and the bonds that were formed to find the difference between the two.